Welcome to my new calculus channel. My name is John Gabriel, and once again, I'd like to talk about the idiocy of mainstream academics. And what comes to mind at this time for this particular video is the quadratic equation and how it is presented and taught by the orangutans in the mainstream. And so I'm going to be talking about that and just trying to tell you the story of when I first saw it and how I learned it. And also how I tried to convince my teachers that, it wasn't written down correctly, even back then when I was still in school. So let me begin by showing you how I decided to do this, or what actually caused me to do this. So I was on LinkedIn and I was reading a comment here by Steve Warner. He is that author and publisher of the Get 800 series of test prep books. So he's going on here about the quadratic equation, and this guy here, Karim Nora, is some idiot I had the displeasure of meeting many years ago, trying to explain to him facts about fractions, but he couldn't understand anything about it. So at any rate, what is the problem with the form, this particular form? Let's go to it. The problem here is that you will see the standard form of the quadratic expression, written like that: a times x minus b all squared plus q. That is actually incorrect. Did you get that, morons? Yes, it's incorrect, and I will show you in a little while it's incorrect. The correct form should be a times x plus p squared. Okay, so back in high school, when this was first explained to me, I just ignored the teacher. The only reason I took to mind what he said and used it this way is because I was a top student and I didn't want him to mark my work wrong. So I continued to use the form that he had actually known, which is this form here, okay? This particular form here. So at any rate, the correct form is this one here. And let me show you how to derive it and what it all means. So what are we doing when we're completing the square? Now notice I've left out the coefficient of x squared, but it doesn't matter. It's just to make things simpler. Normally we factor it out when we're completing the square, and we're only dealing with the x squared and the second term, which is bx, okay? What we normally do to complete the square is we're looking at this as area. So x squared is obviously an area, and so is bx. B being this length here, and obviously the area of this box is bx, yes? So we divide this area here, this particular area here, bx, into two parts, equal parts. And we take those areas and align them with this particular square. And then all that's left to make this a complete square is to add this little area down here, which is obviously b squared over 4. So I'm not going to spend too much time on this document because I'll put a link to it at the end of the video. Now, this method here was discovered by Al-Khwarizmi, who was an Arab mathematician. And you should all thank your lucky stars that he discovered it, because you'd all be too stupid to understand how the Greeks solved quadratic equations, which was far more difficult than this particular method here. But of course, now Al-Khwarizmi showed you this method, but there is another method along the same lines which gives you the same results. At any rate, I show you over here that if you start off with this with this particular form here, okay, and you move down to find the derivative, then you set p is equal to this and q is equal to this so that you get that. And then from this expression here, you must arrive at the quadratic formula, and that's precisely what happens. However, if you use the wrong ubiquitous form, that is this nonsense here, okay, this nonsense, then you would not arrive at this formula. You would have x minus b, which would give you plus b instead of minus b in the final formula, which is obviously wrong. Okay, so, and you can check that in the document. I'll upload it later on. Now, I can't understand why they keep on telling you to think about this as x minus b. I suppose it's due to the fact that usually in an exam or a test, they give you the turning point coordinates, right? And then somehow you're expected to know that if it's negative, then it must be a positive. And if it's positive, then it must be a negative, which is kind of a lot of nonsense to remember. It's, strictly speaking, not correct. Okay, so now you can also derive the quadratic formula by completing the square in a different way. So for example, instead of dividing this area bx by 2, you can divide it into 4 equal parts and then arrange those areas on each side of the square. And then you'd have to complete the square, you'd need 4 little squares, which actually have the area b squared over 16. But because there are 4 of them, it's the same as b squared over 4, right? Makes sense? And of course, I'll show you the derivation when you do it that way, and you get exactly the same formula. All right, so this is just another example, by the way, of something that I've tried to explain to the morons in mainstream academia. I tried on sci.math. Okay, obviously, most of the fools ago, there are a bunch of idiots to begin with, but still, a lot of them claim to have advanced degrees. And you would think that, you know, from somebody like Zelos Malem and his fellow morons who have master's degree in mathematics would have known something like this is incorrect. But at any rate, there are many cranks on the internet. James Meyer comes to mind, and Dennis Muller of Logical Fallacies, and several others like Mark Chukarol and all the other miserable professors, bunch of incorrigible cunts who I've had the displeasure of meeting. Well, I have to ask you to excuse my foul language, but I'll continue to use it because I have a deep hatred for mainstream academics. They are the most jealous, incompetent, arrogant, stupid creatures I've ever come across. And it's really sad that when you present facts to these morons, they simply cannot change their minds. What they are taught is like a religion to them. So anyway, hope you've enjoyed the presentation. This is the New Calculus channel. My name is John Gabriel, and until next time, goodbye.